Hi and welcome to our webinar introducing LYFT 2.2. I'm LP, Product Manager for LYFT System.
And I'm Gabriel. I'm a Junior Application Engineer in the PEC team here at EddyFi, and I specialize in integrating the LYFT system on different integration projects.
Today our agenda will begin with back to basic, explaining to everyone what is PEC and what it does. We'll then introduce our new solution for Scab assessment. We'll go through a demonstration and we'll finish answering to your questions. Before we begin, as you can see on our webinar platform, you can access the user interface on the bottom left of your screen. There is 3 icons that are important. First button is for technical assistance. Second one is for general announcement, and the third one is the most important. That's where you can write your question that we will answer at the end of this presentation. So first.
So back to the basics. PEC, pulse steady current, is an electromagnetic technique where we use a pulse to magnetize a ferromagnetic component, such as it's going to be steel or cast iron basically. We'll magnetize the part, which is going to induce eddy currents inside the steel. We then listen to the decay of these eddy currents, and from that signal we can extract a sizing, a remaining wall thickness of the component. It will work through insulation and weather jackets such as aluminum, stainless steel, and galvanized steel, and it's sensitive to both internal and external defects. PEC is mainly used for CUI, corrosion under insulation applications, but it can also be used to detect corrosion under concrete fireproofing, find flow accelerated corrosion in elbows, and it can as well be used in different specific applications such as cast iron, waterwork piping, or the inspection of deck floors through the coating or the various flooring surfaces.
And to tell you about LYFT, if it is the first time you listen to our webinar, LYFT is our PEC system that has been launched in 2016. At the time we introduced 3 mono element probes with dynamic scanning. We were the first in the market to do that. In 2018 we then launched our PEC array probe. This probe became and remain the fastest PEC probe on the market. But LYFT is not only an embedded software, it's also a desktop software that can enable data analysis and also high quality reporting. The LYFT comes normally with 3 standard mono element probes and also our Pecha cis-channel probe, but you have application specialized probe such as a tank floor underwater probe or a dedicated solution for a galvanized steel probe. And as you can see on the bottom left corner, we now introduce our new Pecha high resolution probe. This new probe is a dedicated solution for Scab assessment. It gives the best estimation of the remaining ligament under scale corrosion. It's a safe assessment of the remaining wall thickness over Scab while the asset is still in service. There is no need of surface preparation, you don't have to remove the scale, and there is no radiation associated with the use of that probe. As you can see on this slide, we compare the data of our mono element probe that is currently used for Scab inspection with this new Pecha HR probe. First thing to notice, it gives a really more accurate sizing. So right on the C-scan you can see the flaws that are deeper. Another nice thing to notice is that it gives a really better signal to noise ratio. With that ratio you can see flaws that you could have missed before.
now we'll present just the range of applications. So this probe is really dedicated for the assessment of scab or blister corrosion, such as the sample we have here, but it will cover a range of lift-off and wall thicknesses that is very similar to the small G2 probe that is already on sale. But it's going to allow to detect smaller flaws than the standard G2 probe. In fact, since this probe has a new sensor design, it's an array of dual sensors with a smaller footprint. It can detect defects that are up to 1.8 times smaller than the smallest detectable defect with the standard small G2 probe. I will now move to the demonstration. So LP is going to bring us this new scab assessment kit. This map is going to allow us to have a constant lift-off while we're scanning over that scab corrosion. We'll now move to the screen of the lift system. So we'll start with the calibration process.
To launch the calibration, the small pulse actually, you can use the probe shortcuts directly on the probe. And then to start, make sure that you're ready and you can press play.
Our smart pulse calibration process is a three-step calibration process. The first thing it will do is find the actual characteristic decay time of the part. From that information, it will set accordingly the pulse duration, the gain, basically all the internal parameters of the instrument. The second step is the calibration. So we'll acquire many A-scans, average the signal of those A-scans, and build the calibration curves. Once this is completed, we'll check for variability in the signal. We'll analyze this and provide a suggestion of averaging setting. The averaging is the number of A-scans we acquire for every sample you see on the C-scan.
In that case, 2 averaging point is more than enough for our conditions.
Since the probe is bidirectional, we always suggest using a minimum of 2 in averaging.
First thing, could you talk about the new A-scan display?
Yes, so this probe is an array of dual sensor. We have 3 elements. Each element is going to acquire 2 A-scan at once. With those dual sensor, it allows us to do a spatial triangulation, and we can really get an effective footprint which is smaller. So we can size and detect and size smaller flaws actually in the part. This is why you see 6 A-scans coming into the A-scan view at once. So every single time we are pulsing with these 3 elements, we're also acquiring data over 6 channels. LP is doing a unidirectional pattern scan. So this is something we introduced in the previous version. You just start at the same actual position for every line, and this gives you a C-scan which is or much better aligned than if you were doing a raster scan. Oh, we got an overspeed. So this is our new warning overlay we introduced in LYFT 2.2. So in real time, while you're doing the acquisition, if you do an overspeed, you get signal distortion or saturation. The samples are going to be flagged right away in the C-scan. You can just roll back, reacquire good quality data over those samples, and move on with the rest of your inspection. And this is really going to allow the operators in the field to do better scans and come back with high quality data to the office. And since this probe is a 3-element array, it really allows for a faster assessment of scab. So it's going to give you that extra edge on productivity compared to a single channel probe. Typically you will be able to inspect scabs such as this one in just a few minutes, which is what we're doing right here.
Also, Gabriel can tell us about the mat. We put it in 1-inch lift-off at the moment.
Yes, so this Scab tool is going to give us a constant lift-off over the corrosion material, which allows, again, for better data quality. It's adjustable in height, so you can put it at 1/2 inch or 1-inch lift-off. You can also use the probe in contact directly with the surface. But the mat is going to allow you to acquire data with a higher quality, a constant lift-off. It's also going to minimize Scab effect, which is the signal distortion you can get from the corrosion material if you're too close to that Scab material.
So then I just finish the scan. I can also use probe shortcuts to stop the acquisition.
Yes. Now that we completed our scan, we will use our compensated wall thickness algorithm to size those flaws. So we will be extracting the contribution from the defect and differentiate it from the contribution of the surrounding nominal wall thickness. Here we get 39% on that part of the defect. On this other part, we size at 34%.
Those results are very good. Previously we did a UT check and we measured that the remaining ligament is 32%. We did it obviously by the inside, which is something that you cannot do while the asset is in service.
Yes, and the seedability is usually going to give you an accuracy of about plus or minus 10% when scanning scabs such as this one.
We'll continue. Something else that you will see on LYFT 2.2 is the data quality that appears in the Excel report. This section allows you to do a good evaluation of your scans, so you can see if you have any trouble during a scan, and it gives you a good idea of the quality of the scan.
Of course, the data acquired with the Pecha Probe is compatible with our 3D reporting software Surface Pro. So if you define correctly the dimensions of the pipe and your scan area in LYFT, you can then import the Excel report in Surface Pro and generate automatically 3D views such as the one you're seeing now. And this is going to allow you to do a high quality report very quickly of the inspection you completed.
It is now time for your questions. So first question, does it work with the LYFT grid? It is compatible only with our array systems, but if you want to upgrade to array, you can actually send us an email and we'll have a look at it with you.
Oh, so someone is asking, I've done a lot of Scab inspection with the small probe. Is it necessary to use the Scab tool to do a correct inspection? Well, not necessarily. What we built here is a solution to really improve the quality of the data and get really the best sizing out of that Scab assessment. But it's okay to use the small G2 probe. Here we're really putting the best conditions in place for you to get the best sizing.
Another question, can I use the Scab tool mat with my small G2 probe? In fact, it was designed for our Pecha Probe, but it is also compatible with any other probe that will fit your needs. Can I use... Oh, that's a good one, Gab, if you want to answer the question.
Can you use the probe on composite wrap repairs? Well, we want this probe for now to be dedicated to Scab corrosion. This is the application for which we qualified the probe. It's more sensitive to everything, including small defects and also change in material properties. So for now, we reserve it for Scab assessment, but the inspection of composite wrap repairs is something that we want to introduce as a new functionality for this probe in the near future.
Can I use the probe underwater? The probe isn't designed for underwater application. It is used only on a dry application. If it's raining, it's going to be okay. But if you go underwater, it is not meant to do it. Otherwise, if you have interest in those applications, again, please send us an email so we can have a look at your specific needs. Oh, easy one. What is the lead time for that probe? It is 4 to 6 weeks at the moment.
Is it the same encoder as the standard probes? Yes, we're using the same encoder as the other standard G2 probe, but we're putting it in the back of the probe to make it easier to manipulate, but it's basically the same encoder you have with your other probes. It's going to be swappable between probes.
Great. Another one. Someone is still telling us that he is doing a rope axis and is not sure about our mat. Fair enough. We know that with rope axis, the mat can be difficult to use, but you can still use the probe in contact. And we also didn't mention it, but we have a grid as you go that fits directly on the probe, so you can also use it to maximize your productivity.
And someone is asking us, is there any advantage to use this probe versus EMAT to inspect Scab? Well, there's a few advantages in using this probe. The first one is that you will be able to size deeper flaws. EMAT is going to be somewhat limited, where the PEC system is going to allow you to size flaws that are down to 15 to 20% remaining wall thickness. So you're really going to be able to assess the extent of the damage, even if it's very deep. Some pipes are going to be covered with thick coatings or even concrete. This pipe has some concrete splash on it. It's not going to affect the PEC signal. You're really going to be able to inspect through the corrosion material and the concrete or any kind of coatings while the pipe is in surface, without any surface preparation.
Yeah, and just to add, as we said, there is no surface preparation, so you don't need to touch the surface. And we know that with EMAT you have to be in a real good contact of the pipe. So that's another advantage, as you said. What is the smallest pipe that can be inspected? This probe is designed to go from a flat surface down to 6 inches diameter pipes. Other questions? Yeah. What is the maximum thickness of pipe that I can inspect with this new probe? As we said previously, it can goes up to 3/4 of an inch, so about 19 millimeters. If the scale has been removed, does it still work?
Yes, of course it's going to work if the scale has been removed to do an inspection with another technique. The lift system is still going to work. If there is a lot of scale, it can affect the quality of PEC signals, but with this probe we really improve the sensor design to minimize the Scab effect, any detrimental effect you could get on the signal because of thick corrosion material.
Someone is saying, LP, you said there are probe shortcuts. Where do I find the list of those shortcuts? Hey Tony, could you put us back on the lift, please? Good? Okay, cheers. Okay, so if you go in the setup, and then you'll see on the far right there is probe shortcuts. If you click on it, you'll see all our shortcuts that have been programmed, and they depend on the context. So the first one is analysis mode, the one that we are at the moment, but you can also see the grid or the dynamic mode, the acquisition. We actually used to stop the acquisition, the last one on this slide previously. Okay. I have a good one for you. Someone is asking us, can I put this probe on my Inoctune crawler?
We are working closely with Inoctune to integrate PEC technology on their crawlers. So if you have a specific need or a specific application that you would like us to look into, just contact us directly by email, and we'll get in touch with you and see what your needs are and try to develop that application for you.
Someone else is asking us if he can use his reference plate to calibrate the system.
This is really something you don't want to do. PEC is a relative measurement. You really have to calibrate on the same test piece that you want to inspect, and then your relative measurements are going to be reliable compared to that calibration area. What we recommend is to make a UT measurement at the area where you calibrated to make sure that your absolute measurements are good. The relative measurements are always going to be good. So that this is what we recommend. We don't recommend using a test plate even if it's the same grade of material to do your calibration. This is not an appropriate inspection procedure.
Okay. Can I use a double resolution like with the large Pecha Probe? Of course you can. All array probe has this option, so you can have a double resolution, which means a very smaller resolution.
I think it's all for the time we had to answer your questions. If you have any unanswered remaining questions, we'll make sure that we get in touch with you and we answer those questions by email. So thank you for being with us today.
Thank you for your time.